Hello everyone and welcome to today's lecture on probability in supply chain management. I hope you are doing well. So in today's lecture, we are going to be talking about quite a few things. And I'm going to start today's lecture off with giving you the agenda. So first of all, I want to just kind of talk to you. I'll start off by giving you an overview of exactly what probability means. And just to let you know, probability is an amazing tool that is used in supply chain management to answer some very important questions, especially questions regarding how much you should make of a particular good. There are a lot of more specific questions, such as the probability of a stock out, which basically means what is the probability that the amount you have is enough to meet demand, or and also, are you going to be able to fulfill the demand in the market? And okay, you can find that out, but also, what is the probability that you run out of goods, meaning that you don't have enough goods to sell to your potential clients? In supply chain management, this is considered very dangerous because if you are unable to fulfill demand, then in that case, customers may decide to go to another company, or choose another brand, and they may never come back to you again. So a lot of companies, really want to find out what is the probability that there will be a stock out. So that's one very important thing you can find out using probability. Another important thing from the perspective of supply chain management is you can find out how much you need to produce to meet a probability of a certain amount. Now, for example, let's say there is a huge increase in demand all of a sudden for a particular good, and you realize as a manufacturer that, look, you know what, it's not possible to meet 100% of demand. But you say, you know what, for the first year, you have a new innovative product in the market. If you are able to meet 70% of the demand in the market, you are in good shape. You will be, and then, the following year you can meet 80%, and the next year after that you can meet 90% of the demand of the market. Now, that's great. You have an idea of how much demand you want to meet as a percentage. But the question is, you want to understand how much you need to produce to be able to fulfill 70% of the market demand. Well, for questions like that, probability is an amazing tool that can be used. And I will explain all of this in a lot more detail. So please don't get overwhelmed. I'll explain everything to you in detail during this lecture. I will also show you how you can make calculations in Excel. So hopefully by the end of this lecture, you will feel very comfortable and get a good working knowledge about how to answer these questions regarding probability in supply chain. I will also be talking to you about the distinction between discrete distributions and continuous distributions. I will talk to you a little bit about probability in both of these kinds of distributions. Again, just starting the lecture off, you may not know these terms. Don't worry, I will explain them to you as the lecture moves forward. All right, so let's start right at the beginning. Let's start, with what is probability. This lecture is about probability, and I'm sure you have at some point studied probability in statistics, but perhaps you need just a gentle reminder about what it is. So let's do that right now. The word probability, if you break it up, you can see the word probable in it. So I'm going to try to explain what probability means by giving you an example. Now imagine that you are in a country that where the weather changes very dramatically, and so sometimes it rains and other times it's completely dry. And so you need to determine whether or not the next day if you should wear a raincoat, you should take an umbrella, and or if you don't need any of that. So you need to look at the weather forecast. Now imagine on a certain day, a weather forecast person says that, you know what, tomorrow there is a probability, that 80% probability that it will rain. In that case, you will most probably take out your raincoat and your umbrella and get ready to face rain the next day. On the other hand, if the weather forecast person says there's just a 5% probability of rain tomorrow, that, or you'll say, you know what, it's very unlikely that it's going to rain, based on the weather forecast. So I'm not going to take an umbrella or a raincoat tomorrow. So when the weather forecast person is giving you these statistics, they are basically giving you the likelihood of an event, which in this example is rain. So they are saying that, how likely is it that it's going to rain? Now, probability is usually measured in percentage terms, but it can also be measured in decimal points. So if they say something like there is an 80% chance of rain, that means effectively that if you are counting, if there are 100 possible cases of what the weather is going to be, 80 of those cases, will predict that it will be raining. All right. So you look at all, so they basically are narrowing it down in order to giving you a ratio out of 100. So they're saying in 100 different possible cases of weather, according to the probability, 80 of those events, out of 100, it will rain. So that's an example of 80% probability of rain. The same thing can be also, written as 0.8. Instead, 80% is basically 0.8 into 100. But if you just keep it 0.8, that means, you are comparing it with 1. So it's 0.8 to 1. And if it's 80%, then the ratio is 80 to 100. So I just wanted to clarify that. And please, when you are answering probability questions, please make sure you check as to whether the question asks you to give the answer in percentage terms or in decimal terms, because that is important, especially when you are going to be answering the problems for probability. Okay, so when you're talking about probability, one of the terminologies that you need to be familiar with and to understand is the difference between a continuous distribution and a discrete distribution. And here you can see on the right-hand side, this one is a graph of a discrete distribution, and the one on the right is a graph of a continuous distribution. The difference, well, let me give you an example. Imagine that you are rolling dice. So maybe you are playing a game of Monopoly, and in Monopoly, when it's your turn, you roll the dice. And there is a probability that either the dice is going to come up out to a 1 or a 2, a 3, a 4, a 5, or a 6. There are 6 different possible outcomes. Each one of them is discrete, independent, outcomes that can happen. There is not going to be, the dice is not going to roll. If when you roll the dice, it's not going to be the answer will not be a 1.256. It will either be a 1 or a 2 or a 3 or 4 or 5 or 6. So there are only 6 possibilities. And so in discrete, you can see there are discrete possibilities, independent, discrete, distinct, separate possibilities of events. Now, if you compare that, on the other hand, to continuous, in continuous, you see that there isn't any, it's not like they're, separate events. There is a continuous distribution, which basically means the outcome could be 0.1, 0.111111, 0.1234. It could be in points. It could be in fractions. There are an infinite number of possibilities in a continuous distribution. One thing to really also mention is in discrete, discrete is basically used to get, specific data points. And I'll, as we move on, I'll show you what those data points are. But usually continuous distributions are used to figure out the, probabilities of certain events happening. Discrete can also be used, but usually by and large, companies use continuous distributions to calculate probabilities. So moving forward, and I will discuss the distinction again later on in this lecture further. So I'm going to start off with continuous distributions first. Okay, so we're going to start off with this, and then eventually I'm going to take you and discuss discrete distributions. And feel free to read these descriptions in your own time. You should be very comfortable with them. It's basically everything that I've explained in a more formal business terminology. And also, if you have any questions on any of these definitions, you're more than welcome to ask me during the question answer session that will follow this lecture. All right, so let's start off with normal distributions. And this graph right over here on the right is what a usual normal distribution looks like. And this shape is also called a bell curve, okay? So it's sort of, that's what it's called. I want to point out a couple of things. You'll see that this point right over here is the highest point. This point is also has this symbol, which is known as mu as well. It's called mu, but it's basically the average or the mean value. So when they're talking about mean value, if you in a normal distribution, you will see it's the middle, right in the center of the normal distribution, and this is the value that is has the most occurrences. So let me give you an example. Let's say you have measured the weight of 18-year-old females, and you have developed a normal distribution, calculated a lot. You calculated about 100,000 18-year-olds, and you put that information in an Excel sheet, and you made a graph then, and it turns out that it's a normal distribution. And what you figured out when you did the analysis is that the average value is 65 kg. So what you can figure out from that is, if it's a normal distribution, that majority of 18-year-olds weigh around 65 kg. So that's what it says. Now, there's going to be some differentiation. Some people are going to weigh a little bit more. Those are going to be on this side. Some people are going to weigh a little less. That's going to be on this side. And you need to sort of understand visually how that looks, what that looks like. One other symbol that you should be very familiar with is the standard deviation, and this is the symbol for that. And standard deviation basically is a value that is given. So for example, if you say the standard deviation is 20, You can say that, some people, the average is 65, and however, there are some that weigh 85, right? And so that's, if that, you can also describe that by saying, the mean plus the standard deviation. You'll say it's a one standard deviation more than the mean. So one standard, if the standard deviation is 20 and the mean is 65, and you say one standard deviation away, that would be 85. So 65 plus 20, which is the standard deviation. So these are just some terms that you need to know. One thing I also want to mention is that you'll notice that the left-hand side, if this was a piece of paper and you folded it right here in the middle, this left-hand side is completely symmetrical to the right-hand side. So very important for you to keep that in mind. Generally speaking, when you calculate, the values, and I'll talk about that a little bit further, but let's say you want to, you're calculating the probability, which seems like, if you look at it over here, let's say, it looks like about 90% probability that you are fulfilling demand. I'm just giving a random example. Then this area will be 90, this, and in the calculations, you'll be calculating this particular area, which means that this area is the probability that you are fulfilling demand, okay? And this red area is going to be the probability that you are not being able to fulfill demand, or that there is a stock out, okay? Now, moving forward, I want to just tell you very clearly that in this lecture, I'm not going to be going on various tangents. There are two particular questions regarding normal distributions that you need to know how to answer. The first one is the probability of a stock out, or the probability that you don't have enough goods and you're going to run out of goods. And for that, there is a formula that you can put in Excel, which is, and you also always remember, when in Excel, when you are writing a formula, you either have to put an equal or a plus sign, and then the formula is 1 minus norm.dist, which is the short form for normal distribution. And here you put in X, which is the amount that you're currently producing, comma, the mean value, this will be given, comma, the standard deviation value, that will be given, comma, 1, and you close the bracket and you press enter, and you will get the probability of a stock out. The other big question that you need to know how to answer after you go through this lecture is how much you should produce if you want to meet a probability of a certain amount. So for example, if I want to fulfill 70 percent of demand, then how much should I really be producing? So for this, the formula is norm.in, and you bracket probability, comma, mean, comma, standard deviation, close the bracket, press enter, and you will get the answer. Also, always remember, either when you are putting in a formula in Excel, you have to put in either an equal sign or a plus sign at the beginning. All right, please do not get overwhelmed with this slide. I know there's quite a bit on it, but again, a lot of it is a repeat. This entire graph is a repeat from the previous slide. And again, the formulas that you are responsible for is the first one and the last one. And I've explained that for the stock out, it is one, there's a little bit of change. It's not exactly this formula. It's 1 minus norm dist, X, comma, mu, comma, standard deviation, 1, and you close the bracket. So again, here's just an example. When you have something given here, n, and 100, comma, 12, This basically means that the average value or the mean value is 100 and that the standard deviation value is 12. And so if you wanted to know that if you are, let's say, producing 85 goods, you want to know what percent of demand you are fulfilling, then you would use this particular formula. Okay, and I will explain this in the next slide a little bit more, and hopefully it'll be more clear to you. All right, so let's start off with the first important question that you need to be able to answer, and I will be giving you practice questions on this for you to solve and get more and more comfortable with. So the first question is probability of a stock out. So again, I mentioned this to you before. You know, what is the probability that you will run out? So in order for you to calculate this, there is the final formula that you'll be using is 1 minus norm dist, and this is the formula, right? But there is a two-step process to solving the calculating the probability of a stock out. First, let's try and understand the steps by going through an example. So this is the example I'm going to solve for you, and while I'm solving it, you will understand how you can calculate the probability of a stock out. So let's read the example together. You are running a manufacturing concern and you're manufacturing 750 units. Okay, so you have a factory, you're making 750 units, and you are told that the average that you usually are able to manufacture and sell is 700, and the standard deviation is 100. So the first thing you need to calculate is how much of the demand are you fulfilling? If you are making 750 and selling it in the market, and usually the mean is 700 and the standard deviation is 100, the first question you have to answer in order to calculate the probability of a stock out is how much of the demand are you fulfilling? And for that, you basically you have to use this formula, which is norm dot dist, and you put in 750, which is the value you're producing, comma 700, which is the mean, comma 100, which is the standard deviation, comma 1, you close the brackets, and your answer will be 0.6915, and if you want it in percentage terms, it will be 69.15%. This is the amount that you, by producing 750, you are fulfilling 69.15% of the demand. Okay, so you've basically calculated this blue value, right? All this blue value. That's how much you are fulfilling. But you want to calculate not the blue value. When you're trying to calculate the probability of a stock out, you are going to be calculating this red value. In order to figure out the red value, you have to take 1 minus the probability of fulfilling the demand, which is 100 minus 69.15%, which is equal to 30.85% of the demand. Now, this is, perhaps just slightly new for you if you've never used these formulas in Excel. So I'm going to show you how you can put these formulas in Excel, and just to get you a little bit more comfortable. Okay, so again, two things in order to calculate the probability of a stock out. First thing you need to calculate the percentage of the demand you are fulfilling. Just please remember that in these questions, you will always be given two values. The first one is the mean, And actually you'll be given 3 values. So the mean in this example that we are going through is 700. You are also going to be given the standard deviation. Oops, take that back just a little bit. And in this formula, the standard deviation is 100. And you will also be given how the amount you're producing. Okay, and in this, again, example, that value is 750. Now, in order to calculate the percent of the demand that you are currently fulfilling, this is what you are going to do. I'm going to make this just a little bit bigger so that you can see everything that I am doing very clearly. So I am going to press plus. I could also press equal. When you press equal or plus in Excel, it basically indicates to Excel that you are about to put in a formula that it needs to calculate a value for. So here we know that the formula is norm.dist. In order to calculate this, this is the formula, right? So I have to put this, it has to say equal to norm.dist. I have to put in X, which is the amount I'm producing, comma mean, comma standard deviation, comma 1, and that will give me the percentage of demand that I am currently fulfilling if I make 750 units. So here we go, norm.dist bracket 750, and here you can see Excel is also telling me you know, how I should all the values I need to put in. So X is the amount I'm producing. Next I'm going to put in comma, and I'm going to put in 700, which is my mean, and then I'm going to put in the standard deviation, which is 100. And then you can sort of see over here in the formula, it says cumulative. Basically, it's just reminding me to put in a 1. I'm going to close the bracket. And after that, I'm just going to press enter. And it gives me, you know, 0.6915. And if I want it in percentage terms, I'm going to take this value and I'm going to multiply it by 100. And usually, you know, the questions are going to ask you to round everything to 2 decimal places. So there we go. And that is the answer. So this is pretty much the amount of demand that I am currently fulfilling. Okay. And this is a percent. So next, in order for me to calculate the probability of a stock out, let me just make that bold. So if I'm fulfilling this much, I need to, the stock out is basically also, another way of looking at it is how much demand am I not being able to fulfill. Okay, and if you're manufacturing 750 units. All right, so that's basically what you are trying to calculate. Now, that's pretty, you know, straightforward and simple. And the reason I say that is that, look, I mean, if you are being able to fulfill 69.15%, you are not being able to fulfill 100 minus 69.15, which is 30.85%. And I'm going to just show you the slide. It says, you know, it will give you the exact same value as I've just shown in Excel. So, you know, I just wanted to make this very clear that everything on, you know, on the slide can be translated in Excel very, very simply. You know, if you are familiar, but you need to understand what's really going on. If you just kind of blindly look at the formulas and you don't understand what the formulas really indicate, then you really won't gain a lot from it. So when you are looking at it like this, and you sort of just, I would suggest that you just lay out the question similarly, then in that case, you will easily be able to calculate the probability of a stock out. Now, this is a very important value, again, from a supply chain point of view, because once companies know that, look, they are producing X amount, and this is the probability of a stock out. If, for example, this value was very high, and they are, the probability of a stock out is like 90%, that's a really dangerous situation. And maybe the company needs to look for another supplier and maybe or increase its manufacturing capabilities. So this, is a very important tool to really understand how much you're producing. Is it enough? Is it not enough? So again, so this is, how to calculate the probability of a stock out. And I hope you understand from an inventory point of view, this is extremely important. All right, so now that we have gone through this example, we've read it out, solved it, first on a high level in this presentation and then in Excel, hopefully now you are a lot more comfortable with calculating the probability of a stock out. Again, extremely important in supply chain management. All right, now next, I'm going to be talking to you about another very important question that probability can be used to solve. And that question is, how much should you produce to meet a probability of a certain amount? So again, let's just dive into an example, because usually with math related, Excel related questions, I've noticed that the easiest way to understand is actually by doing an example. So here is the example. Let's say you want to meet 80% of the demand. You know that your mean is 1,000 and that the standard deviation is 35. You want to know how much you need to produce. So again, I'm going to now take this, and we've discussed that usually for these kind of questions, you need to use the norm.inv formula, and you plug it in and it will give you the answer. But what I'm going to do is I'm going to take you into Excel, and I'm going to solve this with you in Excel so that you are very familiar, and it hopefully will become a lot easier for you. All right, so we are now in Excel, and just like I set up the last question, I'm going to set this question up in Excel. And I highly recommend that you do something like this when you're solving these questions, because it just makes life a lot more easier. So the first thing that we, let's just write right on the top what we're trying to figure out. So what we're trying to figure out is, how much should I produce? Okay, and you are going to be given certain information. So amount of demand you want to fulfill. Let's look at that first. So in the question, it says they want to fulfill 80%. In such questions, 80% is usually translated to 0.8. Okay, so when you're solving how much should I produce kind of questions, you take the 80% and you divide it by 100, and it is the value is going to be 0.8. Okay, so that's the first thing you're going to write out based on the question. Next, you are going to be given the mean. Okay, and the mean in this question is 1,000. Okay, actually going to take this and just kind of write that over here. And finally, you are going to be given the standard deviation. And I'm just calling it standard dev, and that is going, that over here in this example is 35. Okay, so basically you have, you know, 3 pieces of information. The amount of demand you want to fulfill, that was 80%, but when you're solving these kind of questions in Excel, you have to make it into a decimal point. You're not going to be able to put in 80% into the formula. So therefore, you take 80% divided by 100, that is 0.8. You have the mean value, which is 1000, and you have the standard deviation value, which is 35. Okay, so that is, you know, this is basically the data, okay? So this is the data that you have been given, right? Okay, so based on this data now, you have to calculate, you know, what the amount you should produce is. So how are you going to do that? Well, you have a great formula handy. And that is norm.inv bracket probability, comma mean, comma standard deviation, close bracket. So I am now going to put in this formula in Excel for you, so that you can see how I'm doing it. So again, I've gone into this cell over here and I'm going to press equal. As soon as I press equal, Excel, I'm indicating to Excel that I want it to calculate a formula for me. And so now I'm going to just say norm.inv, okay, and brackets, and now it says, okay, you can see over here close to this cell, it's giving the formula already, just to remind me that look, you have to put in the probability, then you have to put in the mean, then the standard deviation, and then close the bracket. So remember, the amount that I want to fulfill is 0.8, so I'm going to put in 0.8, and then you have to put in the mean. And the mean we have been given in the question, that's 1000. And finally, I need to put in the standard deviation. And again, I have that value from the question. So I'm just going to put that in, 35. I'm going to close the bracket. And then after that, now that I've closed the bracket, I've indicated to Excel that I'm done. I've put in all the values. So, and then I'm going to press enter. And when I press enter, it says, I'm telling the Excel, please calculate the value for me based on this information. And the answer is 1029.457. Now, usually it's hard to make, you know, it depends what your product is, but in this particular case, you know, the questions will indicate whether or not you should round it up. In this case, let's just assume that the question required that you round up the value. So your final answer will be, you know, if let's say, oops, hold on. Your final answer will be, you know, 1030, and that is the answer that is also given over here. So if basically what this means is, if you produce 1030 units of a particular good, in that case, you will be fulfilling 80% of the demand. Now, this is really good news, because now you can really figure out, okay, you wanted to fulfill 80% of the demand, and therefore you need to produce 1030 units. So you can go to your factory and say, please go ahead, produce 1030 units. You make a calculated decision that this year you will be fulfilling 80% of the demand, and that's that. So this is very useful information. Again, you have a certain amount of the percentage of the demand that you want to fulfill in mind, and this is kind of the opposite of what you did in the first example. Here you are calculating an exact amount of values that you are producing. In the first example, you were calculating probabilities of fulfilling demand, probability of not being able to fulfill demand. Here you are calculating value of how many goods you need to produce. So this is basically how you solve these two very crucial pieces of information in supply chain management using probability and Excel. Okay. Now, before I move on and I start talking to you about discrete distributions, in the beginning of the lecture, when we started our conversation about continuous distributions, I showed you a normal distribution, and I showed you, a bell-shaped curve that looks something like this. And these are all just examples of normal distributions. What I did want to tell you is that for the sake of this class, I am going to keep it simple, and I'm just talking about normal distributions. And normal distributions are, the most common in supply chain management. However, there are, other ways of calculating. There are other kinds of distributions, other kinds of continuous distributions. One of them is uniform, where everything is kind of the same. There's also a triangular continuous distribution. I just want to let you know this, but I do not expect you to know uniform continuous distributions or triangular continuous distributions. For the sake of this class and for for the questions purposes and all of that, just I just want you to focus on normal distribution, but I did want to put it out there. You should know that there are other types of continuous distributions as well. Okay, now that being said, let's now, let's now continue our conversation and move on to discrete distributions. So I'm going to start off by talking to you, about the example that I started the class off with when I first mentioned discrete distributions, and that is the rolling of a dice. And it's kind of uniform, right? Like the answer that you're going to get, the probability is the same. The probability, that's why your heart kind of jumps a beat as to what number is going to come, because there's kind of an equal probability. Either you can get 1, a 2, a 3, a 4, a 5, or a 6, and the probability of getting any of those values is 1 divided by 6. So that is the, it's an equal probability. So there's a chance, right? It's similar to if you have a coin and you flip it up in the air, either it's heads or tail. There are just two possibilities, and every time you flip it up, you have no idea which side it's going to come. But when you do it like 100,000, a million times, you will realize that the probability of either getting a heads or a tails is 1 out of 2, which is 50%. And similarly, if you roll the die, 1 million or 10 million times, and you make an account of it, you will realize the probability of any one of the outcomes, 1 to 6, is 1 divided by 6. So these are examples of uniform distributions where the probability is pretty much the same of a particular event happening. And so on this slide, you can see the dice over here. And again, if you're going to be rolling the dice and you're going to sort of roll it many different times, you will realize that the probability of each of the outcomes happening is 1 out of 6, because it's a uniform discrete distribution. And so these are 6 distinct events that can happen. That's why it's discrete. And it's uniform because the probability of each of the events happening is the same. The mean of all of these, if somebody says, okay, what's the mean value of rolling dice? Well, the way you do it is 1, which is the first event, the one, it can be an outcome. It could be 2, 3, 4, 5, 6, right? So 1 multiplied by 1/6, because that's the probability that you'll have, the outcome will be 1, plus 2 multiplied by 1/6, because there's a 1/6 probability that the answer will, when you roll the dice, it will come out to a 2, plus 1/6 times 3, plus 1/6 times 4, plus 1/6 times 5, plus 1/6 times 6, and the answer is going to come to 3.5 if you solve that. Okay, um, and I'll talk to you a little bit about calculating standard deviations and what the formula for that is. But this is the formula of how you solve the standard deviation. And the way, again, I'll just go through it. Once you know what the mean value is, the way you calculate the variance or the difference from the mean is going to be this formula right here. So you can look at it in your free time, and you should just know that basically this is how the variance is calculated. Okay, so in a normal distribution, you are going to, A is going to be the minimum value, which is going to be 1, because 1 is the lowest value of that, you can get on the dice. B is going to be the maximum value, which is 6 on the dice. And the number of values that you can get is going to be 6 minus 1. Okay, so that's 6 is B, remember, the maximum value, minus A. So that's 6 minus 1, 5, plus 1. So this is just a formula. So in this case, you have 6, but you may have, 1,000,001. And if you need to know how many values are there, this is how you calculate it. And this is the formula for calculating the variance. And again, here it's, I'm not going to go in great detail, but you can calculate the variance using this, formula here, which is a bit long, or you can just kind of plug it into this formula and you'll get this. If you solve it, you'll get the same answer, which is 2.917. When you take the square root of that, the answer is a standard deviation. So the square root of the variance is the standard deviation, and that is 1.708 in this example. Okay, so that was just a little overview of discrete uniform distributions. Okay, so the difference between a discrete uniform distribution and a discrete random distribution is that when we were talking about, let's say, the rolling of the dice, there was an equal probability of getting a 1, a 2, a 3, a 4, a 5, or a 6. But that's not always the case. Sometimes it depends on what you're doing, but the probability of various outcomes may be different. And if the probabilities are not the same, it's not always the same for every event, then that is random discrete distributions. For example, let's look at this particular case. And right here, you can see if a probability is not uniform and every event has a different probability, then you use the below formula to calculate the average. If you want to know what is the expected value, okay, and you're given a table with the outcomes, okay, these are all the outcomes, excuse me, and this is the probability of each outcome, then the way you calculate this is 1 multiplied by 0.14, which is 0.14. Then you multiply 2 by 0.22, that's 0.44. 3 multiplied by 0.3, 0.9. 4 multiplied by 0.22, which is 0.88, 5 multiplied by 0.12, which is 0.60. And when you add all of these, that gives you 2.96. So the expected value given this information, which is the actual event and the probability of each event, if you are asked to calculate the expected value, then it will be 2.96, and you are expected to know how to do this. All right, moving along now. There may be a situation, and I expect you to know this, where the question is, please find the variance around the mean. And if that is the question, then this is how you are supposed to solve it. First, you simply take, you calculate the expected value, which is all the way up till here. We've already done that on the previous slide. Now, for the variance, all you have to do is take 1, again, use this formula, just you have to make this table and solve it. And I'm going to take you through this table and I'm going to show you how to solve it. So here it's x minus average, okay? So here you're basically going to take 1, okay? And you are going to subtract it from 0.296, which is the expected value or the average. And that will give you minus 1.96. Similarly, you're going to say 2 minus 2.96. Why am I saying that? Because again, it's x minus mu. Mu is here, and 2 minus 2.96, that's minus 9.96, and so on and so forth. You solve all of these values, and then you take this value and you square it. So that these are the values you get when you do that. And then what you do is you take these values and you multiply it with the probabilities. And again, probabilities are given here. All I'm doing is shouldn't be scary at all. You just multiply it by pi. So you take this value that you've calculated here, 3.84, and you multiply it by 0.14, and this is what you get. And when you add all of these, this is going to give you the variance. And if you take the square root of the variance, or square root of 1.48, that will give you the standard deviation, which is 1.215 units per week. Okay, and if somebody asks you what is the coefficient of variation, then the formula for that is standard deviation over mu. You just calculated the standard deviation to be 1.215, and you divide that by mu, which is 2.96, and that gives you a value of 0.411. This way is how you also solve the variance for uniform discrete distributions. I would suggest make a similar table and solve it exactly the same way. So all these formulas and this table stands true for calculation of variance, standard deviation, and coefficient of variation for discrete distributions, and they could be uniform or random. Okay. All right, now finally, just some key data points that companies are very interested in knowing. And these are important for you to know. We have discussed a couple of these. We've discussed variance, standard deviation, coefficient of variation. One thing I do want to mention about coefficient of variation, if the coefficient of variation is between 0 and 0.75, that means there is low variability, it's very stable. if the coefficient of variation is between 0.75 and 1.33, you can say that there's moderate variability. If the coefficient of variation is above 1.33, then you can say that there is a high amount of variability. So this is something to remember. As far as the dispersion or spread goes, a couple of other things. The range, if somebody asks you what is the range, that basically means what is the maximum value minus the minimum value. Okay, so these are terminologies that you are expected to know. Another terminology that is used in supply chain management is percentiles. And a percentile is a measure used in statistics indicating the value below which a given percentage of observations in a group or observations fall. So if somebody says, what is the 20th percentile? Okay, so it is basically the scores, okay, below 20%. So let's just have a look over here, okay? So somebody says 0, 1, 2, 3, 4, 5. These are the possible values, okay? Let's say these are the scores on a quiz. Somebody says, okay, can you tell me what is the 25th percentile? Okay, so since there are, 5 various options, the 25th percentile is going to land, right around here, okay? And you'll say that the 25th percentile, basically this means everything, below 25%. So pretty much all of these values below 25% is going to be the 25th percentile. If somebody says, what is the 75th percentile, then that is going to basically include all of these values and not these values over here. So 70, what are all the values basically below, the 75th percentile? So it's going to include all of these values, okay? If somebody says, what is the range? You will know that that basically means the highest value, which is 5 minus 1. So the highest value minus the lowest value possible, 5 minus 1, which is 4. So these are just terminologies that you should be familiar with. So again, 25th percentile, you're talking about, hey, what is the, values, the kind of below, the lower 1/4%, lowest 1/4%. What is their what is their value, okay, or score. All right, a couple of final things for you in this lecture. I need you to know that, if you are ever in Excel and you want to calculate certain statistics, these are the functions that you can use if you have a huge amount of data. You want to find the minimum value, you can easily say equals min, a bracket, highlight all the values, close the bracket, you'll be able to find the minimum value. Similarly, you can use this formula here to calculate the median, this formula to calculate the mode, this formula to calculate the average, the maximum value, the population variance, the standard deviation variance, and the percentile. So you should just know these things. Please, if you are wondering, am I going to give you a trick question? No, I am not going to give you trick questions. I am going to be, expect questions on material that I have spent the most time explaining in this lecture. So expect those kind of questions to come in your exam. And with that, I come to a conclusion to this lecture. I hope you enjoyed it. I hope you really are excited about using these formulas in Excel, learning some new functionalities, learning about probability in supply chain management. This is something extremely important for anybody in this field to know. Thank you very much for your time. And goodbye till my next lecture. Wishing you the very best.